Hello and welcome to the next edition of the BobCAD-CAM webinar series. Today's topic is 3D Programming Bootcamp. This is the third stage or third round. Let's see. Overview. The goal of today's webinar is to understand the ways to use Z-level finish. As you know, my name is Al DiPaolo. I'm the voice of the BobCAD After Dark video series. You can find this on Instagram at BobCAD-CAM, where you can search the hashtag BobCAD, hashtag BobCAM. So, what are we going to learn today? Well, today we're talking about Z-level finish, also known as waterline toolpath. We're going to look at selection, top and bottom of jump, how you control where the toolpath cuts and where it doesn't cut, and then we'll also look at some of the linking options. Now with BobCAD, as always, you can expect fewer steps, better cuts, and more profit. So if you give me just a moment, I'll get my screen set up here, and while I'm doing that, go ahead and just in the question area, go ahead, just a little shout out of who you are, where you're from, what version of the software you're using, if you're using BobCAD. That'd be great. So give me just a moment, guys. Alrighty, excited for today's webinar, I can tell you that much. I really like spending time with you guys here, so it's good. I hope you enjoy spending some time with me here. Thank you, Roger, for showing up today. Erwin's here. Scott, thank you, Scott. Reginald, Roger, Larry, John, Michael, Murray, Rob, Mark, Jay. Thank you all so much for spending some time with me here today. Felix, Charles, David, Tom Atkins. Very good, Tom. David, Bill, Roy, Ron, again, I appreciate each and every one of you spending some time with me here today. Today is going to be a great webinar. Hope you're having an awesome day. I know that I am. So let's see here. Hold on just a moment. All right, so what do I want to do to begin? I want to start with any questions that you guys have. It's really important. Ask away. Anything that has to do with this project would be great. The question and answer, like the question dialog boxes, that's how you communicate with me. So if you have any questions, just type them away. Any question is a good question. There is no such thing as a bad question. And just fire away as many as you have. Okay, Kyle, Tom, David, Charles, all you guys. Let's see here. All right. So where do I want to start off with? Okay, so I want to start off with the Q&A from the last webinar here. Give me a second. Okay, so there were a couple questions that had come in the last time. So as a review, somebody asked, how do you address the stock condition as the part moves through different setups? Okay, that is a really good question. If you guys think that's a good question, go ahead and give me a hands up. If you don't think it's a good question, no big deal. I do understand. A lot of you do. Okay, so here's the thing. As you go through your job here, as you know, BobCAD has a setup. That's a single setup. You can come in here and you can add multiple setups. So we can do another setup. That could be a different orientation of the part. How do you keep track of that? Okay, so the answer, first off, if you have multiple setups in the part, from the top and from the bottom, the simulation does keep track of the setups for you. So it will simulate it cutting from the top, and then it will simulate it cutting from the bottom. But as far as keeping track of the in-process stock, how you handle that is with a special little feature here. So let's go ahead and show you real quick. I got a lot of toolpaths that I want to review with you guys, but where you're going to find this is in simulation, okay? When you guys go into simulation, did you know that you have the ability to save out your stock? You may not have known that, so let me explain how that works, okay? If we go to the Cut Sim tab here, okay, and then it's this button, and I'll tell you this one right here, that's the one. This is the button you want to press. Hope if you like my arrow. I'm so proud of my arrow today. But if you like it, that's cool. Okay, so that is what the button that we want to press. Now, what this does Actually, I'm sorry, I chose the wrong one. It's the one right next to it. Okay, this one. Save stock, save actual stock as STL. This allows you to save out your in-process stock. You can save it as an STL. I do recommend you reduce the resolution, otherwise the file is going to get really heavy. Okay, so as you cut your part, once you're done simulating it, you can save out that stock as an STL, and then you can use that stock in a variety of different ways. Number one, you could create another job and use that STL as the starting stock. Number two, with a lot of these mill professional toolpaths, you're going to see this thing called operation stock, this thing right here, and we'll use operation stock to tell the software the in process stock condition. Okay, so how do you address stock condition as you move through different setups? You're going to use the simulation to save the stock out as an STL, and then you'll use that STL as your starting stock geometry or your operation stock geometry in order to tell the software where the material is. Okay, if that makes sense, go ahead and raise your hand. Let me know that made sense. If it doesn't make sense, write in the question there that it doesn't make sense. And it looks like a lot of you guys are following along. If anybody doesn't understand what that is, Dave, like the yellow circle and arrow. Yeah, I'm really trying there, even though I put it on the the wrong spot. Ron had a question, where do I find the hotkey list? Let's go ahead and knock that one out real quick. If we go to preferences and shortcuts, you're going to see all the hotkeys are listed here. And also, if you'd like, I have a document with some hotkey, like a PDF. So if you want a copy of that, just go ahead and let me know, and I'll email you off a copy. Okay, so that was the first question. Can you process the stock through simulation and be able to track it as you go through multiple setups? And yes, you can do that. No problem, Ron. I'll get you a copy of that. Okay, the next question that came in from last week was, how is 3D engraving done? That's a great question because, you know, we probably want to put a logo on the top of our part here. And actually, we have some customers that make these. There is a customer, Beans Diesel, that does some amazing covers with engravings on it, and he polishes them. He actually uses Bob art as well. So yes, there are a lot of ways to do the engraving. Probably the most common method that we're going to use, we could project the geometry down onto the surface and use 3-axis wireframe if you are a Mill Standard user. If you're a Mill Pro user, the one that I like to use most often is this one called Project Curves, and that is how you can use your geometry. It's going to be this one right here, and then you have your geometry, and then it projects it down, and then you have some different offset settings that you can use. Okay, so I think you're going to find that project curves or using project curves to surface and then 3-axis wireframe will give you the tools that you're looking at. I make molds. How do I engrave in reverse? How can that be done? That is a great question, Glenn. I'm going to send you an I'll send you an email. Give me your email address, Glenn, and I'll send you a video that I show exactly how to do it. I think I did it on a mill turn one, and there's another video. But if you need to inverse the text, just use mirror. You can do utilities mirror, that will mirror the text, and then you can send that along. Use it for your engraving. Okay, so how is 3D engraving done? 3D engraving is done by either projecting the text down onto the surface, or if anybody else wants that video on how to do the reverse text for like mold making, just go ahead and say yes and provide your email address, and I'll send that off. Okay, so we got project curves. We'll project it down onto a surface, and then we'll use 3-axis wireframe to convert that geometry into Dave. If you guys can't just say yes, you have to say send me that video, because I may not be able to track it all the way down. Okay, guys. All right, so 3-axis wireframe after the geometry is projected onto the surface. And then the other way to do it, if you're a Mill Pro user, is you can use the Project Curves toolpath, which is not just for engraving, my friends. You can use Project Curves in a lot of ways, but that would be the two methods that I can think of. Yes, Scott, I'll send you a copy too. All right. Now, what options do you have for how the tool enters the material? Last week there was a terminology called scrolling, I believe, and it really kind of threw me off. If we go to our leads, we do have a plunge method. With a plunge method, you can do a single depth, a peck, or a fast peck. So that's one way the tool can get into the part. Another way you can get the tool into the part is with a ramp. Or a spiral value. And I think the one that he was looking for was spiral. Okay, so ramp or spiral will work. If you are a Mill Pro user, if I get in here, we have a couple of more options for advanced rough. You have plunge, ramp, spiral, reverse direction of the spiral. Actually, that looks a little new to me here. Oh, this is on Z-level finish. You do have a couple of other options, but you're going to just look under the leads area. If you're trying to control how the tool comes into the part, hey, no problem, John. I'll make sure to get you a copy. If you're trying to control how the tool gets into the part, it's the leads tab that you're going to look at. So let's go ahead and highlight that leads, this area right here. And when you click on that area, it's going to give you your different options and you can choose which one you want to use. Okay. All right. Very good. So that answers that question. Let's go on to the next one here. Can you helical mill and an entry location for drilling versus pilot holes? Okay, so if we're on the cavity side of this and the tool is going to come into the material, and what you want to do instead of drilling a pilot hole and starting there, what you can do is you can helix in, and again, this is going to be that same this is going to be that same setting. Under leads, you can just choose spiral, and that is how that will be accomplished. A question did come in. I think I was told by tech support that loading an STL file, I cannot extract edges because it is triangle geometry, so why would I save my stock as an STL? Great question, Mark. Okay, you'd save your stock as an STL so that you have the in-process stock. And tech support was correct. You cannot create edges or wireframe off an STL because it's a triangulated mesh. Okay, there are other ways in order to get wireframe off a STL or a model, and one of the things you can do, and I'll just do this as a quick example, is you can use the Toolpath Editor. So you could apply Toolpath on that model, and then you could come in and do Edit Toolpath. Here you could select a section of that toolpath, and then you can do this button right here, Convert Selected Toolpath to CAD. It's going to say that it did it. We can say OK, and then what you will see is that is now this line right here is now geometry. Okay, so if I go away from my toolpath, you can see that's now geometry. And that is a trick that you can use with the new Toolpath Editor. Okay, another question came in last week about what is GrabCAD. GrabCAD is an amazing resource for new users. Okay, it's a website. So let me log in real quick on my end. Let me see what I have here. Okay, so this is GrabCAD, grabcad.com. Within grabcad.com, you can search this library for all kinds of things. Let's say mold. Okay, so you can go to mold and they're going to have all kinds of files that you can use. This is a great resource if you're just starting out and you're not really as good with design. You can download some files and then you can practice machining off these files. Now, I do have an account here. And you will notice our 3D Bootcamp file is here, so you can go and download this file. You'll notice there's a couple of other files that I've uploaded over the years. It's just an easy way for me to share files with all you guys. So if you don't have a GrabCAD account, it's free to sign up. I'd recommend you do it. And then you can download files and upload files. It's a great resource. All right, that's GrabCAD. The next one here is, what is the difference between loop and constant Z selection? I think that's another really good question. Let's bring this file up real quick. If I'm in here and I'm trying to do a 2-axis routine and I want to select geometry, okay? Now what I can do is I could click around all these edges. You can see I can do one at a time. and I can click around these edges in order to select my geometry. All right, that is one method of selection off of surface edges. Okay, another method of selection would be to click on one of these edges with your right mouse button, and then you get Constant Z or Loop. Constant Z would select all the geometry that is at the same Z plane. Okay, so if I clear this, I go over this edge, I right click, I do Constant Z, all the edges that are at that same Z level will be selected, so you can see it selected all the way around. Okay, this is when working with surface edges. If you're with Wireframe, you will chain select, shift left click. Okay, the other method to do this is a loop. So if I right click on this and I do a loop is going to pick the edge of that surface. This surface here, you can see it grabs all the edges around the outside of that one. Okay, this one, and this one. And then because this edge is also shared by this top surface here, you can see it grabs the edges all the way around that one. So a loop or Constant Z is just a different way to select surface edges that can speed things up for you. Okay. Moving on, where are runtimes located? This question has come up a bunch of times. So if you are a version 30 user, you're going to go to your milling job, you'll go to Toolpath Statistics, and that's going to give you the runtime estimates for each of your operations. If you are not a mill or a version 30 user, you can go to the setup sheets. Generate setup sheet, and that will give you a runtime estimate. If you don't want to use the setup sheets, you can find it in simulation. When you're in simulation, you'll also find the runtime estimate there. So those are the three places that you will find it. So hopefully that answers that question. Can you see the runtime as the simulation is going? Yes, you can. Yes, David, same thing. If you're in version 25, it would be in the simulation. If you're in simulation, let's see if I have one of these turned on. I think I do. So let's just turn this one on. Post, yes, no. Okay, modules, simulate. Okay, so if you're in simulation, Roger had a question about thread milling. Thread milling is a non-issue. We support single or multi-tooth thread milling. We support taper thread milling, bottom up, top down, cutter comp, side roughing, and multi-start. So all of that is good. Okay, if you are in simulation and you go to views and you go to statistics, you're welcome, Roger. If you go to views and you go to statistics, this will give you your runtime. And as you run this through, it does have the where is it? Total toolpath length. No, I don't want toolpath length. It has, here it is, total machining time. So this is the running time of the job, okay? So you can see that as you go. Model sample from 3D content. Yes, that's actually a really good point. If you're a SOLIDWORKS user, there's Content Central or 3D Content Central, another place for you to download files to work with. Okay, so that covers the runtime as far as simulation go. Reginald had a question about open pocketing in V5. Remind me to email you the video on that so you have that as well. How does top and bottom of job work? And that is a really good question. I'm going to get back to that in just a second. How do you control two-way or one-way cutting? Okay, so top of job and bottom of job is one of the topics for today. When we are talking about two-way cutting, depending on which toolpath you're in, under patterns, okay? So when you're talking about the toolpath itself, right, this pattern section normally is going to indicate, what kind of toolpath, like whether it's a single direction like we have here, bidirectional, or spiral. This one's Z-level finish. So in Z-level finish, you have a single direction, you have bidirectional, which is zigzag, and you have spiral, okay? So the patterns generally will determine whether it's a bidirectional cutting or single direction cutting, all right? So that will answer that. Can you change the machining strategy of an operation? Okay, so this one came up last week and it threw me off a little bit. The answer is no, you cannot. The way that this works is BobCAD is a feature-based CAM system. We are going to create a feature. That feature can contain operations. You can add an operation, you can remove an operation, but you don't really change the operation itself. Either you use it, you get rid of it, add a new one, make a copy, but you don't really change the operation itself. So, okay, that's how that works. How can you just machine the radius on the edge of the part? Last week we talked about a couple of different ways to do this. We talked about project curves as a method. We also talked about morph between two surfaces with mill premium, but probably the more popular way to do this is just to run a planer back and forth, because it's really not necessary in this part. It's not necessary to have a polished finish on this radius. And actually with a lot of these parts, the cusp height or the tool cusp left over is all part of the finish. And the last one that we had here is, what is the link clearance? Okay, this one was specifically for 2D machining, though it does apply to 3D as well. When you're under pocketing here and you're using an advanced adaptive pocket, you will get a link clearance. Geez. Where is it? Okay, link clearance, this number here. So with adaptive toolpath, the tool will cut, and then it will have a non-cutting motion, typically. Cutting, then non-cutting, cutting, then non-cutting. When it's doing the non-cutting, the link clearance is how much it's like a micro lift, is what it's called in some systems. It's the distance the tool moves up off the floor as it repositions. It's so that it minimizes heat and it doesn't drag across the bottom of the floor. Okay, very good. That's a quick fire Q&A from last week. Took about 22 minutes to go through. Hopefully that wasn't too long. Is everybody excited for today's webinar? I know I am, like I said. And I only had one cup of coffee, so imagine that. Very good. Okay. Woo! All right. I like it. I like it. So let's get into what I want to talk about here today. Here's the thing. Z-level finish is like a 3D profile, and that's what we want to talk about today, is this Z-level finish. This is where we have this valve cover. There's actually a taper on the wall. This has a taper on the wall, and we want to come in and just machine that area of the part. Okay, that's what we want to do. We want to come in and machine this area of the part. So when you think of Z-level finish, or you think of sometimes they call it waterline. Okay, we call it Z-level finish. Some packages call it waterline. If we go to our strategies, in here, you're going to see a couple of things. Z-level finish if you're a mill standard user, advanced Z-level finish if you are a mill professional user. So these are the two strategies we're talking about today. Okay. All right. So it's like a 3D profile. It's like 2D profiling, except the difference would be that it will follow. See how there's a taper on this wall? It's going to follow a taper on the wall or any curvature of the part. Okay. Does anybody know the weakness of Z-level finish? If there was one kryptonite for Z-level finish, do you know what it is? If you do, go ahead and raise your hand. Or if you have a microphone and you do, go ahead and raise your hand. No undercut. Yeah, actually, you can do undercutting with Z-level finish in Mill Pro and Mill Premium. Anybody else? Anybody know the kryptonite for Z-level finish? Reginald says he knows. Richard said a flat surface. Actually, no, a flat surface. Well, I guess depending. Let's see. What does Rob have to say? Hey, Rob, you there? Rob does not have a microphone. I wish I had the pro version so I could do an undercut. Yes, I would recommend that. Let's see, Reginald. Are you there, Reginald?
Yes.
Okay, what is the kryptonite?
It does well with vertical cuts, but not very well with horizontal changes, like the top of that part, top of the valve cover.
That is exactly correct. That's what I was looking for. I like the highlighter. It makes it easier. All right, cool. Yeah, that's exactly it. Thank you so much, okay? All right, so Reginald was right on the money there. What we're talking about here is this wall, okay? this wall right here is on an angle, okay? This surface here, this top surface, you can see is really very shallow, and you can see the side surface is very steep, and it's the steep area of the part that Z-Level Finish does really good at. Where it doesn't do very good at is this area here, the shallow area of the part. So let me do that again, okay? The shallow area of the part, this is the shallow area. That is where Z-Level Finish is not going to do very good, okay? Where Z-Level Finish will do very good is the more vertical area of the model, okay? So let's go back to here. Now, all right, so it's like a 3D profile. It's best for steep areas. Z-Level Finish is used to machine more vertical walls or steep areas of your surfaces and solids, okay? So that is really where you need to use this, all right? Now, what are some of the typical challenges users face, okay? What are some of the typical challenges or questions that they have, okay? One, how do I keep my toolpath away from? Okay, so if we look at this toolpath here that I have right now, you can see that it's not actually cutting, or actually it is. It's all the way down here on this bottom surface here, okay, but you can see that it's staying away from these top surfaces there, okay? So how do I control where it's cutting, okay? How do I keep it away from certain surfaces? Another question that comes up a lot is, how do I stop the toolpath from going any deeper? Another question that comes up a lot is, how do I get it to extend past the edge? Now, okay, so these are some of the common questions that come up. Okay, Rob, you're right. Yep, more for vertical walls, okay? These are some of the common questions that come up for sure. And what we want to do today is we want to look at some of the different options that we have for Z-Level Finish. So let's start with the mill standard here, okay? So mill standard, this is a Z-Level Finish routine. The tool's going to run around the part, okay? It's going to go around the part like a 2D profile, except following the curvature of our selected geometry, okay? This one is a Z-Level Finish as well. The difference that I'm outlining here, in Z-Level Finish, let's see, equidistant does better with both vertical and horizontal. Yes, equidistant would be a great catch-all, but it has its personalities too, okay? So when we're looking at Z-Level Finish here, you know, I have this one here. This is where I'm talking about right now is a direct link. You can see the blue line is my lead in, and then this is my link. So that's a direct link. This one is a horizontal vertical link. This one here is a spiral link. You can see how it spirals from level to level. And this one here is a retract where it goes up and goes down. Okay. So I guess that was kind of my third talking point was the links. But when you look at the standard Z-Level Finish, it's very easy. There's not a whole lot that you really need to get familiar with. You have your tool. When it comes to patterns, you don't have any patterns. It's either climb or conventional. When you have parameters, you have your depth of cut, your DOC, your axial depth of cut, how much it's going to step down each pass. You'll notice with Z-Level Finish, there is no step over. There's only a step down that you control. You have your allowance, stock for finish. You have your tolerance, accuracy of the cut, and then you have your depth options. This is your top and bottom of job. That controls where it's going to start cutting and where it's going to end cutting, right? Okay, so we have, in this example here, we have a horizontal link. In this example here, we have this one is a direct link or a follow. This one follows the shape. This one's a direct link, a horizontal vertical. This one's a spiral. And this one is a Z-Level this one's a retract. One of the things that you guys have to keep in mind when using the Z-Level Finish, there's actually a different project that I was working on with a client, and we were doing a cavity, something very similar to this, and we were using Z-Level Finish to come in here and to clean out some walls, okay? The problem that we found is when the tool links, right? I'm using a ball mill here and it's stepping down. This link move here is going to be at the feed rate, the cutting rate, not at the plunge feed rate. So if you're trying to take a more aggressive cut like you would in 2D machining, and you would expect it to, as it plunges or goes down to the next pass, that it would change the feed rate, Z-Level Finish does not do that, okay? It's going to be one feed rate as it, your plunge feed when it gets into the part, which would be like that first move here. So this is rapid down to your clearance, okay? Feed down, this is lead in. This is going to go all the way around the part when it comes back to the other side, which will take just a second. Okay, you can see it's on the regular feed. The regular feed rate here, this back plot's pretty useful for that. It's going to show you feed rate equals regular feed. The regular feed would be your cutting along feed rate, okay? All right, so as we continue to get through here, come on. Let's see where it's at. Oh boy. Let's try to get all the way around the other side here. It would have been a lot of little clicks if I clicked through it the whole time. Jeez. All right, so let's play. Let's speed it up a little bit. All right, pause. Back. Okay. Click through, regular feed, regular feed, regular feed, regular feed. Okay, so there's no change in feed rate as it goes from level to level. Glenn has a question. In simulation and backplot, is simulation and backplot the same? I don't see backplot on my version 28. Backplot on your version 28 doesn't exist, okay? So you would need version 30 in order to have backplot. And actually, I'm going to take a moment to just pause for just a second here, guys. I hope you really enjoy these webinars that I do. I really like doing them as well. I like sharing time. I know you guys share time with me as well. Here's the thing. Sometimes we offer special promotions, okay? Right now, it's the end of the month, and we do have a special promotion, okay? This promotion will include a big discount on products and services. This could be extra seats. This could be add-ons. This can be modules. It can be training, support, service, okay? This is a huge promotion we're running right now. It's for our end of the month special. There's certain company targets that we're trying to hit, and I do need your help in order to hit this target, okay? Now, I don't use this platform as really a selling tool. That's not what this is for. I like helping you guys, but today I'm going to let you know about this promotion that we have. Okay, it's a big promotion. There's a special number that you need to call for this promotion. It's 877-333-4903. That's the number you need to call, okay? If it's within your means or you were interested in adding extra seats, adding a add-on module like BobCAD or Ness, upgrading your module, Mill Standard to Mill Pro to Mill Premium to 4-Axis Pro, whatever the case might be, today's the day to do it. The number is 877-333-4903. I'm going to do it as a chat so you guys all have that number. When you call in off that number, you need to tell them that Al told you to call. Al from the webinar. You were in the 3D Bootcamp webinar, and Al told you to call. If you do that today, you're going to get some very special deals. Okay, I chatted the number to you all so you have it, and that's all I'm going to say about that. Now, getting back to where we were at. When we're doing this, okay, geez, I don't even know where I'm at right now. No, 28 does not have backplot. You need that in version 30 is when you'll get backplot there. If you're a V6 user, you're going to get it there as well. All right. Okay, so we have our links. The links is how it connects from one pass to the other. We talked about the feed rates for that, okay? We talked about Mill Standard. We have our follow link where it follows the surface. We talked about our step link where it goes horizontal and vertical to reconnect. We talked about the spiral. The spiral is probably the most common to do a smooth transition from one level to the other. And the last one that we have here is a retract, okay? Is the deals version 30? It can be any product or service that we offer, Roger. So it could be version 30, it could be version 29, it could be an add-on, it could be anything. Okay, so you got to call, talk to the account manager, let them know, call off of that number that I gave you, let them know that Al said the call from the 3D Bootcamp, and they'll let you know what they can do for you, okay? All right, so we have our links. I started with links. I mean, I don't know if that's necessarily the best way to go. I'm going to jump over to Mill Professional for just a second. There's a couple of things that I want to talk about with Mill Professional. One of the things that users run into quite a bit with Mill Professional is when they first select all their geometry, and then they generate their toolpath, and you'll notice with all of these, I've selected the entire model. I do want to talk about selection, so we're going to go into more detail on that. But when I've selected the entire model here, I'm expecting toolpath to run across the entire model. And with the Mill Pro user, sometimes you're going to find that it doesn't run across the entire model. A lot of times you're going to find that, okay? Why is that? Okay, does anybody know why that is? Let me check you guys here. Let me lower everybody's hands. Do you know? Okay, so if you know why it doesn't cut everywhere where you think it should, go ahead and raise your hand. Let's see. It's looking for vertical walls. Ron, that's a good guess. It's not exactly right. Let's see here. Charles says he knows. Charles, do you have a microphone? Let's see. Let's see if Charles has a microphone. You got a mic, Charles? No mic. Okay, Charles, why is it? What do you have to change in order to get it to cut down to the bottom? Do you know? What you have to change is the cutting extents. Bit size is a good guess. Sometimes the size of your tool, it doesn't fit in there, but exactly what's happening here, if we go under options, let's get the highlighter pen out for Irwin, right? If we go under options here, we have our cutting extents, and the first one is, the default is actually set to extents, okay? So this is what we're talking about here. So with the extents, you know, it cuts to the extents of the geometry. I don't know how else to describe it, but that's the first setting. And when you do that, it doesn't run the tool all the way across the model. It's not even, these walls here are actually vertical walls. The other walls are on taper. I made a mistake when I designed it in SolidWorks, but you know, why isn't it cutting down to the bottom? Well, it's because of the cutting extents. Now, if we look at the same toolpath, but we just say part bottom, all of a sudden we're going to get a lot more toolpath. All of a sudden it's going to cut all the way down to the bottom, okay? So, you know, you got to look at that when you're using the software and you have these cutting extents. You have extents, you have part bottom, and you have 3D extents. This will affect where your toolpath is generated. In this example, it went from not cutting down all the way down to the bottom and not cutting these vertical walls. And what did it end up doing? It ended up filling everything in, okay? But we still got a problem. A, we don't want the tool to run down inside of these holes here, okay? B, we don't want the tool to run all the way, like we don't want to use a ball mill to run this outside edge here because we can just profile that, right? And then also this top surface here, really it doesn't benefit us to have the toolpath run across that top edge there because we're going to do that with a planer anyways, okay? So, our first example, it didn't cut everything we wanted. Our second example, it cut too much, okay? So this is where top and bottom of job can come in, okay? So if we go into this feature here and we go to edit, we go to parameters. Again, you have your depth settings here. You have a top of job and bottom of job. Using these two values that you can enter or pick, you can control where in Z those toolpath, where in Z that toolpath will be generated, okay? All right, so we have, you know, it doesn't cut everywhere we want. It does cut everywhere we want, but now it's cutting further than we want. Now, what if we don't want it to go down in these holes? I get this question asked a lot. How do we stop it from going down in holes? One way to stop it from going down in holes is to check ignore holes. This button right here. Now, here's the thing. In order for it to know to ignore holes, the holes have to reach or they have to have a certain geometry condition. They have to actually be a hole or what the software considers to be a hole. If you are clicking ignore holes and it's still going down in the holes, what do you do then? So let's go ahead and compute this. This is ignore holes here. It will take a second to calculate. When it gets done, you can see these holes meet that geometry condition, and it's stopping the toolpath from going down in there. Okay, so what we're going to do now is we're going to uncheck that. Let's say that let's say that the toolpath is going down in there and we check that and it didn't work. It didn't stop it from going down in there. The next step to do would be to plug the holes. This is generally what I'll do is I'll plug the holes, and I'll show you what I mean. I'll recompute. That's the wrong one. Hold on. Cancel. Okay. I will recompute the toolpath here. And we'll see the toolpath will go back down inside of that hole, okay? So let's say I checked ignore holes and it's still going down in that hole. How do I stop it from going down into that hole? What I'll do is I will cap it. I will generate a cap surface. In this case, I'll choose planar, and I'm just going to put a surface on top of it, okay? So now those holes are blocked. Now, because I've made a design change, I need to reselect my geometry. So what I'm going to do is just add these cap surfaces to my selection. I'll go ahead and recompute. And then what we'll see is by capping the tops of those surfaces, the toolpath will no longer go down into that area. So we did have a solid model, and then we also have surfaces that we're selecting as well. This concept here is a very useful concept. These are capping these surfaces. This is kind of pre-check surfaces, but it's a very useful tool. And the reason why is you can use surfaces to block the tool from going into certain areas. It's a neat little thing here. So I went ahead and moved them up. I'm going to reselect my surfaces that I've selected or that I've created here. I'm going to recompute, and then what we're going to see is that they're going to be blocked. They're not going to go any deeper than that area there. Okay, so that's one way that you can handle that. You can see how it blocks it and then it goes around it. You can use surfaces in order to do that. Okay. Let's see what else we have here. So the other thing that we wanted to talk about is, like, controlling where the toolpath cuts are. Okay, so let me back up just a second. So we have selection, right? Selection, what we've selected, and again, selecting the whole model and then adding additional surfaces can give me control over where the toolpath is cutting or not. Why would I not, let me remove my selection here. Why would I not just select the surfaces that I want to cut? Why would I not select this, okay, as such? The reason why I wouldn't do that is when you select just a few of the surfaces, only the surfaces that are selected are used for gouge protection. So, what's going to happen is the toolpath's going to run around that surface on both sides, and that doesn't make any sense, okay? So for new users, I generally recommend selecting everything, but if you're a more advanced user, you can choose to select specific surfaces, not selecting everything. And with your experience, you can sometimes generate what you need. Sometimes if the file's bigger and there's a lot of surfaces, you don't want to select everything because it takes longer to calculate. So as you're working with your 3D programs, I do recommend that you select all the geometry, but as you get more comfortable with it, you can select less, okay? So that's one thing, is your selection. Now, the other thing that I want to look at here, give me just a second, guys. Let me see what else I have on my agenda. We have top and bottom of job and linking. Selection, top and bottom, and linking. Okay, so again, when it comes to selection, generally we're going to want to select the entire model. Okay, can I ask a question over the mic? Yes, you can. Let's go ahead and find you. Can you raise your hand for me so it'll make it easier to find you? This is Richard. Hold on just a second. Okay. Are you there?
Hello?
Yep, I can hear you. What do you got going on today, Richard?
Hey, I was trying to program something over the weekend, and ideally I kind of wanted to use cutter comp and be able to loop the levels of the cut, I guess cancel cutter comp and swing a loop like what you're showing in your under the one of your toolpaths, the 3D toolpaths, the spiral, yeah, the spiral lead in and lead out. is there a toolpath that'll use cutter comp and spiral off of that level and spiral into the next one?
No, no, you're not. In the 3D toolpaths do not use cutter comp. There's no cutter comp setting for any of the 3D toolpaths, so it's not going to post the G41, G42. It is possible to, using advanced posting blocks or editing the code, it's possible to put cutter comp in there, either through a special post processor or through manually editing the code. But then what you're asking is, I want to lead in and lead out and use cutter comp on every level. What I might do instead, how many step downs were you talking about, Richard? A lot or what?
Yeah, it was a lot. I went like 3 inches, 3 3/4 down, taking about 200,000 steps to cut each level. 200.
Yeah, so you got quite a few. You could do them with section planes. Like, one way you could do this is to do section planes at every level that you want, so you could go to a level and then you could generate the wireframe for that level and then use that wireframe to do a profile, you see? That way you would get your cutter comp, but that would require you to do that a bunch of times, right? So, the other way it's possible that you could do that. I don't have the Mill Premium toolpaths on here, but with the Mill Premium, you do have the option to do a lead in and lead out between your profiles, right? So like in Mill Standard, like if I go to this horizontal vertical, you can see that it will do a direct connect, but it only does a lead in at the beginning and then it does a lead out at the end. It doesn't do a lead in and out between each level. It just does a direct connect, right? When you're in the Mill Pro, you're going to find the same thing. Let me see here. Let me get it to a different one. Well, this one's a spiral, so that wouldn't have a lead in and lead out. What is this one? This is the adaptive. This is adaptive, and this one's with a spiral as well. But okay, so what I'm telling you is with the Mill Premium toolpaths, you could use a lead in and lead out for each pass. And then with an advanced posting tab with your post processor, you could actually put cutter comp in it. You could have it lead in, call cutter comp, and it could do that for every level. But it's not an in-the-box solution. It's something that you'd have to pick up. Okay?
Okay.
Does that make sense?
Yeah. Basically, like if I wanted to do that, I'd have to have edit a post or have a custom post done to like helical off and helical in at the new level.
The
canceling and turning.
Yeah, the post processor is just going to post the cutter comp. The lead in and lead out, in order to get the lead in and lead out, you can use the Mill Premium toolpath for that. Okay. So I'll tell you what. Let me get back to the topics at hand, and let's connect after the webinar, and I'll show you what I'm talking about. Okay. Sound good?
Yes, sounds good. Thank you.
Yep, no problem. All right, very good. Thank you for the question. I think that was a good question. Now I just need to find you. Okay, cool. All right, very good. Now, so the next thing that I want to look at here, well, there was a question. Ron said, where are the section command at? So if you go to view and then section view, that's where you're going to find that command. Okay, so view section view. I think that was in 29, maybe. I'm not sure if 28 had it, but that's where that one is located. Let's see, another question came in. Can I change the default setting for machining tolerance in V5? You can't change the default setting, Reginald, for these toolpaths. Like if you come in, the default tolerance is very accurate. The only way to save what the default would be saving the feature. When you save the feature, it will save the tolerance that you have there. Okay. You could do it with a calculating sub. Roger, I think what you're saying, if there was no taper on the wall, then sure, you could loop it, I believe is what you're talking about. So using a subroutine, but yeah, okay. All right, so again, when we're talking about selection, let's see, let's bring the model back up. Generally, we want to select the entire model. When we're talking about top and bottom of job, this is where we're going to start controlling levels in which it's cutting in. Okay, so like, let's go to the spiral routine here. You can see that I'm going to spiral the tool around. And the reason why I'm showing this is with the advanced Z-level finish, you do have a spiral as an option as one of the patterns. Okay, so if we edit this feature here and we go to patterns, you'll see spiral is one of the options, zigzag or zig for advanced Z-level finish. But again, I have it starting, just below this radius, and really I would actually want it above this this flange or this shoulder that's here. Okay, so how I control the levels is with this top and bottom of job. I'm just going to go ahead and clear that and recompute this. And what you're going to see is the toolpath is going to cut across the entire model. And we don't always want to do that. Sometimes what we want to do is we want to control where it's going to start cutting and where it's going to end cutting, okay? And using your top and bottom of job is how you're going to accomplish that. Now, I think 2 versions ago, maybe it was 2 versions ago, they added this pick top, pick bottom, okay? So you used to have to, you had this option in the past, but you had to enter these values. You couldn't pick it off the model. And the reference point for the top of job is based off your machine setup. So depending on where your machine setup is located, that definitely could be a problem for you. So now, as far as what the measurement is. So now using your pick top or pick bottom, it makes it a lot easier to figure out what's going on as far as where in Z that value actually is, or what that value in Z actually is. Now, Charles had a question: can top and bottom be defined at the same time? It's 2 as far as workflow. First, you set the top or bottom, then you set the bottom or top. You can't select them both at the same time. You have to select one at a time in order to set the top and bottom. So hopefully that makes sense. All right, so again, restricting where the toolpath is cutting in Z, we can use top and bottom of job to accomplish that, okay? Now, another way that you might look at this here, let's go ahead and what do we got? This is the adaptive step down. So again, this is kind of showing the difference on the spiral routine. You can see really on the shallow area of the part, we're not getting a lot of toolpath. In this particular one, this is using the adaptive step down. The adaptive step down will take additional passes in order to clean up this area of the part here. Let's go ahead and show that real quick. If we're under parameters here, you can see adaptive depth of cut is checked. If I turn that off and I recompute, what we're going to see is we're going to see toolpath tightly grouped along the vertical walls, but along the shallow areas, it's not going to be tightly grouped. When we add the adaptive step down, then what it will do is it will tighten up that toolpath on the shallow area of the part in order to give you a more consistent finish. So this is without the adaptive step down. It barely touches any of the surface area here. When we come in and edit this and we go to our parameters and we say adaptive depth of cut and we recompute that, we're going to see that toolpath tighten up on the top of the model. Okay, David had a question. When was adaptive step down added, if you know? It's MilPro for sure. And, I'm not sure. I think it's version 28 maybe is when they added adaptive step down. After a good couple versions now, it's really hard to remember where they all are. But if you're not sure, there is a toolpath matrix on the website where it does a version comparison and will tell you which options are in which versions. And you'll find that. Version 25 Pro, yeah, you're a little behind, David. You would be one of the potential guys that it would really make sense to take advantage of today's end-of-month promotion. So, make sure you write that number down, 877-333-4903. Al said to call, products, services, training, add-ons, extra seats, everything. Talk to those guys. Get the MilPro. V30, you'll be glad you did, or potentially the premium because there are a bunch of really cool toolpaths in there as well. Okay, so again, this is using the adaptive step down, and you can see it really does clean up that surface quite a bit more. Again, in case if it's not clear, this additional area here, all of this tightened up toolpath on both sides, all the way around on this top area of the part, that's that shallow area. And without an adaptive step down, we could tighten the step down for the entire part, but then that's just a waste of time and a waste of motion. So I wouldn't necessarily recommend that, but that is an option for you. Okay, let's get back to here. All right, so we got about 5 minutes left before the end of today's webinar. Real quick, I did a Q&A at the beginning. If you guys liked the Q&A at the beginning from the previous week, just kind of as a review, if you think that that's something that you would like to see continue to happen, go ahead and comment there that that's something you'd like to see to continue to happen. I kind of like starting off that way, so that's pretty cool. The other thing is I'm going to open it up to open question and answer, so anything that you guys have that you want to go through, let's go ahead and pick that up. We got about 5 minutes left before the webinar is over. Let's see, there was a question that came in from David. Is Toolpath Editor select Toolpath to CAD to create wireframe from STL available in 29? No, David. The Toolpath Editor is only available in the version 30. It was a big part of the version 30. So what I want to do here is I'm going to, let me turn everything off, everything on, everything off. I'm going to go to this one here, and I'm going to say, I'm going to edit this. I'm going to edit this, and I'm going to make this a 1-inch end mill. I'm going to recompute this. This is going to generate some information. I think you guys do like the Q&A at the beginning, so I'm glad to hear that you guys like that. So we're going to try to keep that in. We're in stage 3 of the boot camp. We only got 2 more to go. Oh boy, this has been a good one. I look forward to seeing you guys in the next one. I know we're running out of time here. I know some of you guys got to go, but all right, what am I going to do? I've generated my toolpath here. I'm going to turn this one on. I'm going to launch simulation here. I'm going to run this through the simulation. Mark has a question. In Sim, how do you reduce the cut precision report so we get more green surfaces, plus or minus 001 instead of plus or minus 008 RAN? You can adjust the report. I guess it depends. I'm not sure of the specific setting that you're asking there, Mark, so I'm going to have to look at it. Give me a second. Okay, so from here, I'm going to turn this out. I'm going to go next stop. What it's going to do is it's going to process that model there, okay? Once that model is done, here is all our toolpath, or our in-process stock. It did a bad job, but that's okay. We're going to save this out. We're going to reduce this tolerance here, 0.001. We're going to say save, okay? It's going to save it. Once it's done being saved, we're going to close this, okay? Now, it looks like some of my audio may be running into an issue, so bear with me, guys. But now, what I'm going to do is I'm going to create a new file. I'm going to merge. We lost connection. I'm not sure if we're live or not, guys. We're going to go to STL. We're going to bring this in. Here's our model. From here, we can run our wizard. From here, I can't tell, guys. I think we are not connected anymore.